Hi, I'm Sanat Bhaskar, a security researcher at reinfosec.com. I and my teammate Vijay, would like to present it to Resploit. Resploit is a tool used to understand the telecom network and the security of the core network in a telecom deployment. Now let's look into a demonstration of telecom network deployment and a brief introduction on telecom networks, that is a 5G network.
Let's look into a 5G telecom network. 5G network introduces the usage of high band spectrums, which broaden the coverage of 5G network over mediums from 1 GHz to 5 GHz and lower bands, which is less than 1 GHz as well, extending its coverage with respect to the previous generations. In this way, with the help of multiple input and multiple output, this network can transfer a great amount of data at the same time, performing as stated in a better way. Nevertheless, in a quick time expansion like this, the security aspects are not taken into account as much as it should. Let's look into the 5G in a nutshell, where the 5G core network is 20% more power efficient and the 5G towers is 40% more responsive, which results in a 10 times faster efficiency. Now let's look into the features of a 5G network. There are two phases. First one, the non-standalone and standalone networks. Each 5G network starts its deployment in non-standalone mode, as shown on the screen, which means the 5G radio access networks, that is a RAN, is linked to the Evolved Packet Core (EPC), that is a long-term evolution core, that is an LTE core. Therefore, the network in non-standalone mode is not completely based on the new technology. Indeed, despite this combination of components, the 5G network is still able to offer better performance than the 4G. For this reason and because of the reduced cost and the time during implementation, 5G NSA took hold. In addition, even if the services offered were not totally provided by an end-to-end 5G network, the latter can still be employed as a foundation. A 5G architecture consists mainly of an UE, a UPF, that's an user plane function, a data network as shown on the screen. An operational network is shown as shown on the screen, where a RAN has 2G, 3G, 4G, and small cells, where as well as a core network and an OAM network is connected to the operators as shown on the screen. The 5G architecture works on network slicing. Network slicing technique is a fundamental method that brings a lot of benefits for the 5G network. Indeed, different use cases based on the needs of the customers can be implemented in a single network using the so-called slice. The idea behind network slicing is that it allows to reassign resources from one virtual network slice to another one. 5G network slicing technique can be defined as a configuration who enables to implement multiple independent and virtualized networks over a single physical infrastructure. Now, let's look into a 5G core network. So, a 5G core is one of the main components of the 5G network, which consists of a wide variety of storage and processing resources. All these assets can be leveraged by users on demand, depending on the specific needs of each of the customers. 5G Core indeed implements a totally virtualized environment, enhancing the portability and the usability of network systems and services. This is possible due to the network slicing and the fundamental mechanism for the implementation of multiple virtual networks over a single physical network infrastructure. From a high level point of view, we can assume a picture as shown in the screen. Now, let us look into an implementation of a core network for testing our tool. So, we are using a core network called Free5gc. It's a little step back has to be taken here in order to set it up. Firstly, as a non-standalone combined with fourth generation EPC, that is an evolved packet core. Subsequently, in the same year, also has been implemented the standalone 5G core features. In this section, we will look into how to set up a free 5G core network in a virtual box, which comes aid to build the environments. Indeed, if the core has any topology of weakness, it has to be employed with formally deployed any other operating systems for security testing like Kali Linux, exactly with the same specifics. So we are using a recommended Ubuntu version as shown on the screen. Let's look into a setting up of free 5GC network in a virtual box.
Free5gc. First, we are gonna start our Free5gc and Ueransim Ubuntu servers. So then we are going to SSH into this from our machine. So we are gonna basically use two different instances of a terminal. One is for Free5gc and the other one is for Ueransim for convenience. So let's increase the font size by a bit. So we are gonna SSH into Free5gc whose IP is 192.168.56.1. So we can find out this IP by logging into these servers whose username is Ubuntu and password is also being set the same. So we have config and then find out the IP address of the Ueransim server to be 192.168.56.102 and that of the Free5gc to be 192.168.56.101. So using this IP address, we SSH into these servers from our machine terminals. So we are going to SSH into Ueransim now. Yeah, now we are going to start running the Free5gc and Ueransim setup. So first we are going to run the command is equal to 1. So entering the sudo password. The next we sudo ip tables -t nat -a post routing -o anps 0 s3 -j masquerade. So we can find out the interface to be ENPS03. In some systems by default it might be ENP0 S4 or S8. So we log in into another instance of Free5gc. So here we can see that our inet interface 10.0.2 is ANPS03. So we're gonna stop the firewall. Sudo system control stop UFW and sudo service UFW status, and we can see it's the uncomplicated firewall and it's inactive. The UFW service is inactive. So now we are gonna put them to IP tables. Sudo IP tables -i forward 1 -j accept. Now sudo IP tables -t nat -s. So we can see here the post routing -2 ANPS03 is there. Now we are going to check it for IP tables -s. Yeah, and we can see that forwarding is being absent. So now we are gonna change the directory to Free5gc. We are gonna verify what all changes that has been made. So now we'll run. So now the UPS has been started. So in the second terminal, we'll SSH into Ueransim and start the command make. So after it's done, we're gonna check with getDef. So we can see that we have changed AMF configs address from 127.0.0.1 to our Free5gc IP, and the type from OPC to operator type to OP, and such changes have been made. And now we are going to build using the command build nr-gnb -c config /free5gc -gnb.yaml. So we're gonna hit enter. Yeah, now the ng setup procedure is successful. Now we're gonna SSH from another different instance of the terminal into the Ueransim. Change directories to Ueransim. Then we are gonna build sudo build /nr -ue to build the user interface -c space config /free5gc -u user interface .yaml ueransim. Here, after building the GNB, Free5gc's GNB, we are building the Free5gc's UE. So, and we can see here the connection setup for video session has been successful, and the tunnel interface USM tunnel 0 is up, and the registration accept is being received. So, as we can see here, the USM tunnel is open, and it's from 192.168.56.102, which is the Ueransim, and USM tunnel is on 10.60.0.1. And we can see the UPF GPT in Free5gc are running. So we'll start the web console for our Free5gc now. So we'll change directories into Free5gc and web console directory, and then we are going to execute /bin /web console. So our web console is also up and running. And from this we can observe that it is listening and serving on port number 5000, and the IP is 192.168.56.101 for Free5gc. So if we are going to use that, http (192.168.56.101:5000/. So we are redirected to the login screen. So we log in using the credentials admin and Free5gc. So here we can see the real-time status of our registered UEs, and this is the configuration for the UEs, and it states as connected, and we can also see the IMSI number also. So these are the subscribers that has been registered, and while adding a new subscriber, we'll make sure that the operator type is set to OP, not OPC. So this is the subscription description, the IMSI number which was of the UE before subscriber which had been shown, and these are the configurations for the same. We can see the tenant ID and the tenant name, which is admin, and we can modify those details too. And this is the UE charging for the subscriber that we have. So this is the 5G network setup that has been up and been used for the testing purpose. We can see it's still running, and this is the Free5gc web console.
Resploit is a tool used to analyze the security aspects of a telecom network. As of now, we have integrated a bunch of tools like Nmap, Dicto, and further etc. tools. So, in a future scope, we would like to integrate a TLS analyzer to analyze the TLS transactions, and for a future scope of work, much more tools can be integrated. The details of the code is being uploaded in the GitHub repository and shared in the submission. Thank you.
This is Resploit coded using PyQt in Python, and this is the GUI interface of Resploit. It has various tools such as Nmap, Wireshark, Metasploit, Nessus, AircrackNG, Burbsuit, Nikto, Hydra, John the Ripper, OpenVAS, SQL Map, Snort, and Dirbuster. In the future scope, more tools are to be included in the next upcoming versions. So the first field is the IP field, and here I have the Free5gc and Ueran. Free5gc 5G network running. Here the Ueran is up and running, and the IP of the Free5gc machine is 192.168.56.101. So we are going to scan in Nmap for that range. So we can perform different kinds of scans such as OS detection, version detection, ping scan, intent scan, and quick scan as the user wishes to do. So we are going to scan 192.168.56.0/24 range for a quick scan. So in summary, the scan shows that the target machine 192.168.56.101 has two open ports with detailed information about the services running on these ports. Port 22 is running SSH on Ubuntu, and port 5000 is hosting an HTTP service likely related to Free5gc web console. The scan includes service detection, host key information for SSH, and supported HTTP methods. So we are going to open that using a web browser, and we are going to log in into Free5gc. So this is the status of the Free5gc 5G network running. This is the UE charging and real time status and the subscribers data. So since we got the address as 5000 port, we can check it with any other tool such as Nikto. Using Nikto, we can perform different scans here that are cross-site scripting scan, database injection scan, mutate scan, SSL scan, full scan, and basic scan. So we're gonna enter the address, that is http 192.168.56.101:5000. So we're gonna run a basic scan over here. So the key takeaways from the output of the scan is the scan found that the web server is missing the X-frame options header, which is a basic security measure to prevent cross-site scripting attacks. The server has uncommon headers and potentially interesting endpoints such as login and status, which typically mean they could be potential attack vectors or sensitive areas of the web application. And no CGI directories were found, which is generally a good thing, but could be further explored with additional options which are also present. And the one host was completely tested and no CGI directives was found. This is the output. And let's check it out with Derbuster. For directory traversal, we're going to perform a basic scan with Derbuster. So this is the result of the Derbuster scan that we performed. So here it is using the word list file common.txt and URL base as http 192.168.101.56.101 and port 5000. And these are the outputs of the derb scanning result. So in summary, the output indicates that derb tool attempted to brute force directories and files on the target web server, and the scan did manage to identify 3 valid directories or files on the server, which were login, status, etc. So these are the various scans that could be performed. And here we can also see the output of different scan options in the same place, such as after performing a ping scan, what the output was, and then shifting into the quick scan after finding out the host was up, and we found out the input gives certain output. And this is a snapshot of the code of Resploit.